Hello, my name is Professor Michael D. Robertus, and I'm an astronomer with the Department of Physics and Astronomy here at York University in Toronto, Canada. I want to welcome students and instructors alike to this set of modules intended to better prepare students for an introductory science-based astronomy course. I've taught introductory astronomy courses for over 30 years now, and I've noticed two things over that period. First, almost every student has a real interest in astronomy, whether they're astronomy majors or simply taking the course as an elective. Second, very few students entering the course are aware of the basic nature and rhythms of the night sky, whether that's because of pervasive light pollution in our cities and communities, or because they're always looking down at their devices. Astronomy, apart from being the oldest of the sciences, is a science firmly grounded in observation, and a basic familiarity with the night sky really helps students grasp important concepts more quickly in an introductory course. It's also important that students receive a brief but accurate overview of the history and evolution of astronomy, at least up until the end of the scientific revolution, especially because astronomy played an important role in the emergence of the scientific revolution. For all these reasons, I've designed a few modules to be used as a supplementary resource for science-based introductory level courses, which will provide students with a much-needed foundation and free up valuable lecture time for topics that require a deeper connection with physics and mathematics. The modules then are the introduction, that is this module. The second is the celestial sphere. The third, the history of astronomy. The fourth, an introduction to Stellarium, which is a free open source planetarium software. The fifth, the horizon or altitude azimuth or azimuth altitude coordinate system using Stellarium. And finally, the equatorial coordinate system, again using Stellarium. To conclude this introductory module, I'm going to take one moment to motivate the study of astronomy and illustrate its widespread usefulness and appeal. Astronomy is deeply rooted in all cultures. Essentially, every culture for which there are records has been acutely aware of the day and nighttime skies. Can you imagine how different our cultures would be if we lived on a perpetually clouded planet like Venus? Astronomy has had important practical applications for many cultures, such as for timekeeping and navigation. Before the advent of higher technologies, cultures made use of the stars for telling times and seasons, as well as directions. Astronomy is among the most dynamic of the sciences, advancing areas in other sciences such as mathematics, physics, geology, computer science, and even biology. In a related way, astronomy is used as a vehicle to teach important concepts in other areas in science and technology. Astronomy has a profound aesthetic and emotional appeal for many. In our quieter moments, we perceive the universe as awesome and beautiful. Studying astronomy helps to satisfy humankind's innate curiosity and appeals to our sense of exploration. Astronomy increases the public's awareness, interest, and understanding of science and technology. News outlets are always eager to promote the latest major astronomical discovery, often accompanied by spectacular images. Very few sciences have as broad an appeal as astronomy, which after all is a hobby to millions of people of all ages around the world. And perhaps most compelling of all, astronomy is concerned in part with humankind's place in time and space, our cosmic origins. That is, how we came to be and where we are headed in the future. This concludes this introductory module. When you're ready, begin with the second module, the celestial sphere.